All right, so we're about to be 2 minutes over, so I think we can get started here. Welcome everyone to the fourth ever Mud Core Dev Call. We run these every month, and every other week between these, we also do community demos where people share their Mud projects. So thank you all for coming along. We also just want to give a thanks to all of our contributors that help make Mud possible. We have, I don't know, somewhere in the, what is it, about like 15, 16 contributors, something like that. The ones you see in red here, Boffy, John Grant, and Yonada, have been people that have contributed since our last call. So thank you for your contributions. If you are at all interested in contributing to Mud, I'm going to drop a link in the chat in just a moment. You can go to contributors.mud.dev, and there's going to be some good first tasks for you to take on. And we're always welcoming more contributors. But with that, Alvarius, Frolic, and I think Yonada also, we have some really exciting updates for today, so I'll pass it over to them.
Oh, thank you very much. All right, so as always, we're going to split the call into two halves, the update call. First half is going to be on-chain, and then second half is going to be off-chain stuff, so everything that's not on-chain, meaning clients and indexes, etc. First exciting news on the contract side is we've actually frozen the MUD contracts on Monday this week, and we handed the commit over to the auditing firm, which is going to start an audit upcoming Monday. And then the audit should run until approximately DevConnect. And then after that, should be audited after we fix any bugs they potentially find. And one exciting side effect of that, until the end of the audit at least, there most likely won't be any breaking changes to the contract. So it's going to be easier to upgrade between different alpha versions because no more breaking contract changes. And then once the audit is complete, we can then finally recommend MUD in production. So that's going to be very exciting as well. Speaking of which, earlier this month, we found a critical vulnerability in MUD and fixed it. If you haven't already, you should definitely upgrade to the latest alpha version. The way we fix this vulnerability is by preventing the vault from calling itself now, and also systems or like contracts that you register as systems in the world basically have to implement the system interface now, which is by default the case if you just extend the system-based contract. But yeah, it's basically no longer possible to register arbitrary contracts as systems and then make the world call them. So upgrade to the latest version if you haven't already, but I think most people have probably. Then a couple exciting features. So basically, since the last core dev call, like a lot of things happened. You can check out the change log to get the full list of all changes. So we won't go over all changes since then because it's just way too many. But here's a couple exciting new features that we've added. The first one is account delegation. I briefly teased that in the last core dev call, but I didn't really go into much detail. And now it's actually part of MUD, so I'll explain you what it means. So let's say we have Alice. Alice is any account on Ethereum. And Alice wants to allow Bob to call functions on her behalf, essentially. And so what she can now do in MUD is she can register a new delegation for Bob, and then she can pass a verifier contract that either is a custom contract or one of the built-in standard ones. And then once that's done, Bob can now call methods on behalf of Alice using the new call from entry point. And then the methods are basically passed on to the system by the world. And to the system, it just looks like Alice would be calling the system. So the systems don't need any changes to integrate this new feature. And then in some cases, Alice might want to give an unlimited delegation to Bob. So Bob can call any functions in the world, and also as often as he wants, and also as long as he wants. But there might be other situations where Alice wants to restrict the types of functions that Bob can call, or maybe she wants to restrict the time in which Bob can call these functions. And that's why we have these verifier contracts. So in the most simple case, if it's an unlimited delegation, you don't need to pass a contract, or basically you pass a constant that like identifies the unlimited delegation as the verifier. But in other cases, you can pass verifier contracts, and there's a couple built-in ones. For example, we have one that is basically call bound. Essentially, you can restrict access to certain functions in the world, and we have one that is time bound, so you can restrict the access until a certain block number. But it's really easy to build any custom verifier. We might ourselves add more like standard verifiers in the future. but also everybody can basically create custom verifiers that verify a specific type of delegation. And also, it's not only possible for individual accounts to register delegation verifiers for individual other accounts, but also per namespace. Namespace owners can register a verifier for the entire namespace, which then means anybody who calls the namespace goes through that verifier. And that, for example, is one example use case of that would be trusted forwarders that a namespace could implement. And then only that namespace accepts calls from that trusted forwarder, and other namespaces might accept calls from other trusted forwarders. A couple other use cases of that is session wallets, a very simple implementation of session wallets. Like right now, most mod apps use burner wallets, meaning there's a wallet created in local storage, and then that's where all the actions come from. But once the wallets have some valuable items in them, you might not want to have the wallet in your local storage, or you might not want to execute actions, like from a wallet in your local storage that has valuable stuff in it. So one very simple way around that is we can have a main wallet, and then we can create a session wallet, which for a limited amount of time and for limited functions can call stuff in the world on behalf of that main wallet. But that's not the only use case. Other use cases might be what I just mentioned before, trusted forwarders on the namespace level. And also this whole pattern in general is inspired by the ERC20 approve and transfer from pattern, which on the ERC20 side allows atomic swaps as an example, because the contract can essentially withdraw tokens from the user account, and then in the same transaction also send something to the user if the withdrawal was successful. Now in MUD, you can essentially do the same, but not only for tokens, but for any system interactions. So that was feature number one, account delegation. Now let's continue to world balance, another change we added since the last MUD CodeDev call. Previously, the way MUD handled ETH being sent to the world was by just forwarding the entire ETH to the system. That was a problem because of two reasons. Reason number one is systems are supposed to be stateless because they can be part of multiple worlds. But if you send ETH to the system, then that essentially is a type of state that is now in the system. And that might lead to security issues if the system is part of multiple worlds, because now potentially multiple worlds could have access to that ETH in the system. And then also the other issue with that approach was if you have like some sort of you have some multiple systems that want to interact with each other and that are part of a larger system. Then before, only one system had the ETH and other systems couldn't access that ETH because it's stored in the other system. Now the way it works is the balance, so the ETH that is sent to the world, is not forwarded to the system contract, but rather it's stored in the world contract, and the world contract keeps track of all the balances of all the namespaces in the world. And then a system or anybody who has write access to that namespace can also access the balance in that namespace. And now that solves both problems. First of all, the systems don't have any state anymore in the system contract, but also the different systems that are part of the same namespace can now interact with the same balance. So you can have one system that receives the balance, and then another system can maybe spend the balance. So that is the next feature. And then the third feature I want to mention here is ephemeral tables. What they were called before are now called off-chain tables. We rebranded them, and also we slightly changed their feature set. So before ephemeral tables, the only thing you could do with them is basically called set record on them, and it was similar to an event that you just emit, and then it still goes through the sync stack, but you couldn't, for example, delete a record. Now we changed that to make off-chain tables basically almost feature-complete tables, but with the one main difference, the state is not stored on-chain, but only events are emitted, and that means the indexer can sync the tables exactly like regular tables, but it's much cheaper on-chain because state is not stored on-chain. That means you can't get the state, so you can't read the state on-chain, but you can still read it from the indexer. And the only thing you can't do in terms of writing to the table that you can do with normal tables is pushing to dynamic fields. And the reason why you can't do that is we need to read the some stuff about the field from on-chain in dynamic fields. And since nothing is stored about the off-chain table on-chain, that's not possible. But you can still set the entire dynamic field if you wish so. All right, so that's a couple features that we added. We also added a bunch of gas optimizations since the last core dev call, mostly thanks to DK1A and Buffy, who did a lot of work here. I'm not going to go through the details, but they're all listed in the changelog, so you can, if you're curious, you can have a read there. And now I will pass it on to Yonada, who will talk about another feature that we added to the contract. Specifically, Yonada added it. And so we'll pass on the mic to Yonada.
Cool. Hello. Yeah, thank you, Alvarius. Yeah, so in the past couple of weeks, I added this batch call system to Mud, which basically allows you to atomically call many systems on your behalf in like a single transaction. So this basically turns like all Mud users into a smart contract wallet. Because originally, like on Ethereum, if you're just using an EOA wallet, like a regular wallet, you can only call like one contract at a time. Whereas like Mud, we've registered this batch call system on the root of the world, so it can basically set you as a message sender when it calls all these systems. I think maybe to illustrate the point better, I can explain like why I started to build this in the first place. Next slide, please. Yeah, cool. So I work on SkyStrife, and in SkyStrife we want to try and we have like a lot of different systems, but we want to keep the API as lean as possible. So for example, right now we need to create matches, set an access list for who can join the match, and then people need to be able to register for the match. Next slide. But we also want to have really nice UX, where basically sometimes we want to call all three of these systems in a single atomic call. So maybe you like create a match, you set the access list, and then you register. And this can get pretty gnarly if you implement it naively. Next slide. Yeah, so if you try to do all this atomically, you basically just have to copy paste a bunch of systems, and you end up with like, if you take all the combinations, you'd end up with like 6 different systems if you wanted to do any combination of these. So next slide, please. We just implemented this one batch call system that can accept. Basically, it takes like an array of like system IDs and call data, and it will call all those systems for you. And we're using this like pretty heavily in SkyStrife now. It's been pretty helpful. Yeah, I think that's all I had to say. Basically, you guys are all now smart contract wallets.
Nice, amazing. Yeah, so the batch call system is part of the default modules of Mud now. So anybody using Mud can use batch call now. Thank you very much, Yonada. And now let's continue with the off-chain part. And for that, I would like Frolic to the stage. I think he's already on the stage. Yeah, let me know when you want to share your screen and I will stop sharing mine.
Yeah, so just a quick overview. Previously, we had a SQLite indexer. We've since added support for Postgres. So given a Postgres database, you can run the store indexer and it will grab all the data from the chain and sync it into a nice Postgres database with structured tables and columns and everything that you're sort of used to in a relational database. So I want to do a quick demo. You can give me the screen share. Can you see my screen? Minimal mode client?
Yep.
Yeah, we can.
Great. So I have the React template running Mud right now, and I also have separately a command running the Postgres store indexer. I'm currently running this from the Mud monorepo, but we are also out publishing Docker images. So in the docs, if it's not already, it'll soon have commands you can run to spin up the indexer from a Docker container, making it super easy. You don't have to install anything really. But I'm going to go ahead and start the indexer, which will, like the previous indexer, detect where we're at in the current indexing state as far as block number and continue indexing. So if I increment the counter, we can see a bunch of these queries coming through and incrementing the data. And so the exciting thing is, if I open up Table Plus here, I can see in my database a counter table, and if I refresh, I can see the value is 7, which corresponds to the counter value. So if I increment a couple more times, counter value is 9, and I can refresh, and counter value is now 9 in the Postgres database. So we have some meta columns. You don't have to worry too much about those, but the main one is the value column, which is, in this case, it's a singleton table, so we don't actually see the key columns, but if you had keys, a key schema, you would see those as proper columns as well. But yeah, the primary thing is this value column. And then we also have the internal tables for both store and world in here. So if you want to explore what is registered for internally for getting sort of a mud world spun up, you can see all those in here. Yeah, I think that's basically it for the Postgres indexer. I have another slide that Alvarius would go to, but I'm just going to move on. The other thing we wanted to show is a new ABI-TS package that we just published. So previously we had all of our types for contracts being generated through type chain, which had a dependency on ethers. We've since removed all, with the exception of our deploy CLI, which is soon changing, but pretty much all templates are using VM natively. And through VM, if you want strong types, you need to provide it a strongly typed ABI. The way that TypeScript works currently, you can't get that out of a JSON file. With sort of JSON alone, you would end up with string types as opposed to the string literal. So we've put out this nice utility which basically takes all of your ABI files and adds a type definition for each of them. So when I import this iWorld ABI, for example, this is the world for our template, React template. We can see very strong types kind of trickling through. So we're seeing like actual UN256 string as opposed to the sort of generic string type. And so then when we get down to our world contract, I can have world contract dot write dot. We can see all these methods that are strongly typed and available to us. And it's an incredibly lightweight CLI. I can also show. Let's see. World. So yeah. This ABI JSON file is what gets outputted by Forge when we build our contracts, and then ABI-TS basically takes that and declares the types for this, which is essentially the same thing we had here, just a little bit of reformatting to make TypeScript happy. And then you can import the JSON file as if it were regular JSON, but strongly typed. That's it.
Very cool. Thank you very much. Let me share my screen again. Okay, you should see the slides again.
Yep.
Cool.
Yep.
All right. Yeah, so those were all the changes that we will go over in this call. But as always, you can head over to mud.dev/changelog to see the actual all changes. I believe in the last dev call, the latest version was next 3. So there's a couple of changes, and especially the last 2 are pretty big ones. So yeah. Hopefully the last like big set of breaking changes on the contract side, but we'll keep iterating obviously on the client side. But yeah, we'll try to keep the breaking changes to a minimum. Cool. All right. With that, there's a couple other links as always. I think the red one I will hand it back in a second. But for the first 2, if you want to contribute, if you want to start contributing to Mud and want to like start with small issues that don't require a lot of context, you can head over to contribute.mud.dev. We try to keep a list of basically small issues there that people can just use to basically start diving into Mud, to contributing to Mud. And then we have the status.mud.dev page, which is basically an overview of Mud features and their current status in terms of stability and whether any changes are expected in the future. Yeah, and in terms of contributing also, if you want to like become a more serious contributor or even co-dev, then always feel free to reach out to one of us. We're always happy for more people on that front. And now we'll hand it back to Kushal. So.
All right, thank you, Alvarius, and great presentations, guys. So yeah, the last thing in this slide that I want to call out is this newsletter.mud.dev. So if you go to that link, you'll be able to subscribe to the Mud newsletter. We'll be sending out regular updates that include a lot of the stuff that we cover in these core dev calls, but minus the details. So kind of just a quick overview of what's changed in the past week, what's on our roadmap, and everything like that. We'll also be calling out events, linking to like YouTube highlights and stuff like that. So it's a bit unstructured right now. We're just starting it, but you can feel free to kind of subscribe there and follow our progress. So next slide. In other news, we also have this community event calendar now. So it's a public Google Calendar that you could subscribe to, or alternatively, you could kind of like allow notifications on the event calendar channel in Discord. Either of those options should keep you really up to date for any core dev calls coming up, community demos coming up, or any other events that we have planned. And then last slide here. And lastly, we are going to be, the Lattice team is going to be in Istanbul for DevConnect, and we're also going to be having this event, the AW Assembly, Autonomous Worlds Assembly. So if you do want to apply to attend this event, you can visit aw.network/2023. And we have some exciting speakers lined up for that, and you can learn a bit more about it at the link. And I think that's all for community announcements. And now we can go right back to the actual Mud Core Dev part of this, which is going to a Q&A. So if anyone has any questions, feel free to come up on the stage or ask them in the chat. All right. Any questions at all? Going once. Going twice.
You only get this chance once a month. So if you have any questions, do now.
Oh, right. We have 2 people requesting to get on stage. Let's see. I'm going to bring you one at a time. YQ, I'll bring you up after. All right. Welcome, UC Wireless. What's up?
Hey, sorry, brand new to this, to using Mud, so this might be just a naive question, but curious if there's a repo out there or an example out there of being able to almost import an external NFT as a character into the game, into the world contract almost. Current thought is maybe like wrapping the NFT that is a character in almost like a separate player contract and attaching the components to that. But curious if there's any examples of kind of importing external characters into the Mud world.
Great question. I'm not sure if we like on the Mud docs or anything have like examples of that. I'm pretty sure that people have done this kind of stuff at like I've seen this kind of stuff being done at the hackathon, like at the ETH Global Hackathon, for example. There's also another approach that 0x Hank was following, which is essentially re-implementing the ERC like standard, like ERC 21 and ERC 721 standards in Mud, so that you have basically a more native integration. So essentially, the thought there is if you have an external like NFT contract, it's possible that like you can have systems that then interact with that NFT contract. That's no problem. But if you have the NFT integrated into the world directly, then you have more possibilities of different systems writing to balance tables, etc. Actually, now that I speak of this, I realize that I think SkyStrive is doing something like that. So maybe you have additional thoughts.
Yeah, I mean, so we worked on kind of creating our own, creating our own ERC20 or ERC721 tokens from scratch. And basically the way that works is you would deploy kind of like an interface contract that implements all of the ERC20 methods. But like inside that, it actually calls into the Mud world and modifies the state of the Mud world. So from the perspective of an indexer, it emits all of the ERC20 events and has all the right methods, but the state is like ultimately still managed within the Mud world. Obviously for external stuff, you can't really do that, so it's a little bit more hard. But at the end of the day, like systems are still validity smart contract. So they can call out to any external like NFT contract that you wanted to.
Yeah, the only downside is these external NFT contracts or any external contract won't get the sort of well-formed store events and therefore can't take advantage of our whole sync stack. So that's one of the benefits of MUD and one of the things that you don't really get by interacting with other contracts, but they're still just contracts, so contracts can call other contracts, so should have no problem there.
Gotcha. Thank you. Yeah, a few ideas to work with then.
All right, great. Thank you, EC Wireless. Let's bring YQ on stage now for his question.
Hi, team. Great presentation. Also, first time here. So I have actually two questions. The first one is if we really want to onboard, a lot of users, for example, 1,000 users, and have a lot of entries in the work contract. On your side, did you test what kind of state? Will there be state explosion after a few months? Have you tested that out? So roughly, we would like to learn some experience on that.
Mm-hmm. So you likely wouldn't run into issues on the on-chain state itself, because that's basically like bottlenecked by gas costs still. The thing that you might run into issues with is like loading the entire state from the indexer, but we're working on like more powerful like filtering mechanisms from the indexes so that you don't have to download the entire state. Essentially, we're doing that also right now. We're running a 2-week playtest with Skystrife, which is the game we're developing in-house with MUD, and also realized that, like, in practice, that it gets slow after sometimes if the state is growing too much. So we're experiencing this basically firsthand, so you can be sure it will be fixed.
I see. So roughly in your previous stress testing, right? Roughly how many entries we can encounter some similar issues like that?
So we had, I think the biggest in general, stress test that we did with MUD, it was the previous version, but like conceptually it's still the same, was with OPCraft last year. And I believe we had around 10 million entities. And I mean, loading the initial state took a while. Like it took like 15 minutes on a browser client, but it was still possible. With Skystripe, I think we have much less entities than that. But still, like we want to get to basically the point where you only load the entities or like the pieces of the database that you actually need for the specific part of the app. So in context of Skystripe, for example, it would be you only download the entities that you need for a specific match of Skystripe. And then the goal is that you don't have to wait a couple minutes to download the state, but rather have it almost instantly.
I see, got it. Yeah, the second one will be like, right, for some games, like we help our partners to build, like we help them to launch the like dedicated rollup and just to sort of have more performant environment for them. So right now, do you have some recommendation on this rollup stack and do you also think like pre-compile can also help to reduce some of the performance load for some of the contrast states? Yeah.
So we don't really have like a real recommendation right now. We might be announcing something at DEF Connect potentially. Maybe not, but I can't talk about it yet. What I can say is we likely at this point won't have like custom precompiles because we like our philosophy is rather we want people to build for the EVM and then be able to switch between execute the stuff on different chains without custom precompiles for the game, which runs into a bunch of issues downstream. But yeah.
I see. Got it. Yeah. Thanks for the replies.
Cool. Thank you very much.
Thank you, YQ. So yeah, I realized that permissions were accidentally off for typing in the chat this whole time. So now if anyone has any questions that you want to type into the chat, now you'll be able to. Sorry for any confusion there. Discord permissions are a little bit tricky.
Oh, a lot of people typing now.
Yeah. Several people are typing. I've actually never seen that before. I've never seen so many people typing at once.
Right. Who's gonna win the race?
Right now, how to address RNG and Oracle issues.
I guess so. I assume you mean like RNG, so randomness, and Oracle issues. So there isn't really anything specific in MUD for that. So you would basically have to use the like existing solutions of Oracles. In terms of randomness, also same there. I think actually Ori from our team published an article at some point talking about like how to get randomness on chain depending on your requirements. Maybe we can find that. I think Ori is not in the call, unfortunately. But yeah, so essentially nothing specific to MUD here. We also don't have a specific solution in MUD right now, but you can use any of the other existing like solutions for on-chain randomness and oracles.
All right, and then we have another question here. Is it possible to host data and indexers on third-party data providers?
Yeah, absolutely. All the packages are open source in the MUD repo. They're available as npm packages as well, and Docker containers. So you're welcome to run that anywhere you've got a connection to a SQLite or Postgres database.
Great, thank you, Frolic. Okay, and then we have, along with the combo about ERC20 and 721 integration, is there a standard for badges, non-transferable, that is caught on and is worth implementing as well?
Like nothing that I know of, honestly. I guess you're talking about, so it sounds like you're talking about general standards and not like nothing much specific, but in both cases, the answer would be the same. I unfortunately don't know. We also haven't, so basically in the, like on the MUD side, on the MUD contract side, in the last couple of weeks and months, we've mostly been focusing on basically getting the core foundational contracts ready and stable for the audit. So we haven't really spent a lot of like capacity on, like, for example, implementing standards in a MUD native way yet. But now that the core contracts are done, that might be another area of focus of ours. Okay, next question. When you mention audit, does it include open source MUD contracts? That's specifically what we're auditing. So basically, all the MUD contracts are open source, as you probably know. It's like in the MUD repo. And specifically what we're auditing is the store package and the world package. So those include all the core MUD contracts, and those are being audited.
Okay, and then we have can storage hooks from this advanced features part of the docs be used to have subsystems automatically run logic on a table change?
Yep, so that's exactly basically the intended use case. So essentially, brief 101 on storage hooks is you can run a system. So basically honestly any contract a contract that implements the storage hook interface. You can register that on a table if you own the table. So if you own the namespace of the table, then you can do that, and then the hook can do whatever it wants, including also running subsystems to then automatically like change logic. Your hooks can then even change other tables, and then those changes could trigger another hook. The only thing you have to keep in mind there that obviously all of this costs gas, and so you probably shouldn't have too complex and too far chained hooks there, because then you might run into block gas limits depending on the chain you're running on.
All right, and can we it looks like Alireza might be asking a follow-up, so let's give that a second. So we can keep context there. And the hooks would have to be set up on deployment?
It not necessarily. So we don't currently have any like support for hooks in the TypeScript deploy script. The easiest way to do it would be either in the post deploy script that's a forge script that's being executed after the deploy script runs, or in any other either forge script or contract or a module. So you can, the easiest way would be basically to set it up in some kind of smart contract code. Modules actually are a really good solution for that, or scripts. So you can think of modules essentially as scripts that are deployed to the chain, so you can run them on different worlds if you have to. So you can basically deploy the module once, and then it's not going to change anymore, and you can install it on different worlds. But maybe also a quick addition to that is, if your question is hooks would have to be set up on deployment, you can add a hook at any point later. So you can, if a table is deployed now or registered now, you can register a hook on that table in a year and it still will work.
All right, great. Looks like that answered all of Ali Rez's questions. We can move on to Skygirl's question, which is, can we index based on specific contracts? Is there a place to configure the contract address?
Yep. When running the indexers, any sort of variant of it, you can specify a world address as an environment variable, and that will just look for events from that world address.
Great, and it looks like we have a last question here from T-Pay. Are there plans for upgradable smart contracts? If it's loosely based on the EIP 2535 standards, can you upgrade individual systems?
Yes, since the last, this is one of the updates that didn't make it into the presentation. But yes, since the latest versions, you can upgrade systems as well. So essentially, it's great. So basically, you can deploy a world. We actually used this week as well for the Skystrife playtest, where we live patched a couple of the systems, and it seemed to work pretty well. And so yeah, systems are upgradable. Again, there's no support in the deploy script yet in the TypeScript version. But the recommended and probably most straightforward way is to create a forge script and then just interact with the world. The way you upgrade a system is basically just by register the system again with the same ID, and then that overrides the previous mapping to the previous address.
All right, and just in case somebody didn't see it, Kushaba said, can confirm the Skystrife update was straightforward and worked well. So that's already been tested and worked. All right, so we have time for one more question if anyone else has any more. Any plans to get ETH Denver? I am personally not sure. Any of you guys?
I don't think we're currently planning to go there. The conference we're going this year, the big one is Dev Connect in Istanbul, but probably not ETH Denver.
All right, well, unless anyone has any last thought, I believe that's it for today. So thank you everyone for coming to the 4th ever Mudcore Dev Call. Like I said, we do these every month. If you want to be up to date on when these events are happening, we do have a public Google Calendar event calendar. You can visit the channel event calendar, and I'll also drop a last link here before we part. But otherwise, look forward to seeing you all soon.
Thank you very much.
Thank you.
Bye-bye.